Hit present. Very good. All right. So we are talking about dynamic routing with the IPv4 and IPv6 types of routing.
We have to say our names, don't we?
No.
Okay, cool.
I think they know who we are at this point. So the starting off is the evolution, and so IPv4 was first. It was used in the 1980s when it first came out. It was the first version of routing IPs to be issued for use, and it was used longest and still the one I'm most familiar with. However, nowadays, even though it's still being used and it's provided for the means of computers and internet connection that we are all very familiar with at this point, we are starting to run low on how many there are these days around because there's so many computers and there's only so many IPs that IPv4 can make that we're getting running low, and so eventually we needed a new type, which is IPv6, which came out not too long ago. I'd say it was about maybe good 2000s or so that was actually issued, in which the advent allowed it. So it's a lot different. If you look at an IPv4 and IPv6, there's a huge difference in what the IP looks like, and so it's more complex. But when it emerged, newer versions of it, it's now a lot more efficient at adding IPs to new things, especially now that in this day and age where not only computers can have IPs, there's like smart technology and almost everything from appliances to even cars now. So,
Advantages of IPv4 and IPv6. For IPv4, it allows for about 4 billion addresses, and IP allocation limits those public IP addresses to a few hundred million, and it's easier to read, remember, and better supported. For IPv6, everything from appliances to automobiles can be interconnected. IPv6's simplified packet header makes packet processing more efficient.
Ooh, that's me. Okay, so let's start with IPv4, even though I put it on the right. We're weebs. Okay, so the most glaring issue is the lack of addresses that are still available. So, eventually we're going to run out of the IPv4 stuff, and then we won't really have much opportunity in that sort of style of routing to actually assign more addresses. Configuration, you either have to manually configure it or use DHCP, Dynamic Host Configuration Protocol. And with DHCP, you could have a much larger network, so a lot of companies and stuff use it, but the thing is you have to actually keep the infrastructure going, like upkeep and all that. And security. So there's some built-in stuff, but it's optional and not always there. So RIP. IPv6, yeah. So there's one of the biggest issues with that is conversion. So because IPv4 is on most of the things that we have had until now, it's going to be a bit of a transition period to actually convert to IPv6. Communication, the two machines can't communicate directly with one another. So given the fact that we still have all this IPv4 stuff, it's just a part of conversion. It's just going to make it difficult to transition. Yet again, the transition, it's going to be pretty tedious. And for readability, because it's a, I think, 64-bit address or whatever, then it's like you have more. Huh?
I think it's 32.
No, this is for IPv6. IPv4 is 32. But yeah, it's just longer. And if you think it's annoying to try to memorize an IP address now, it's going to get even worse if you have to do it with IPv6 one. So yeah.
It could be hard for me. You're like that big bit, so.
Alright, the similarities between IPv4 and IPv6 is that they both are versions of the internet protocol, and they both have the private addressing. Both are connectionless protocols, and they contain destination address, and they use packet switching.
The IPv4 and IPv6 differences. The IPv4 has the address length of 32, and IPv6 doubles that in 64. Address representation is 4 decimal numbers from 0 to 255 separated by periods, and IPv6 is 8 groups and 4 hexadecimal digits separated by colons, and the packet header for IPv4 is 20 bits long, while IPv6 is 40 bits long, but simpler than IPv4. Configuration is manual or through DHCP, and configuration for IPv6 is auto configuration of address is available, and IPS supports optional, and for IPv6 it's already built in.
I have a question.
Okay.
You said IPv4 is 32 bits.
Yeah.
IPv6 is how many bits?
64.
It's
Sure.
128.
I believe it's 128.
I found it
I
was.
don't know. I didn't put that.
64.
I didn't do that slide. So
Okay. Please ask another question now.
What's better in your opinion, IPv4 or IPv6?
Even though it's not widely used there, I still find IPv6 better off, since it's a lot more applicable to more than just PCs, and you can have a lot more addresses with it. It's just gonna be a slow, tedious process to get all the IPv4s replaced with IPv6, to get everyone to understand it, to get everyone to get used to it, and for it to become the norm eventually.
yeah, it's like with all technological advances, there's always a transition period, and a lot of times that period makes things difficult for people. So
Anyone else?
I chose over.
We need to pick someone. We need a second person.